today's video, we're going to be taking a detailed look at a set of civil construction drawings, and I'm going to be talking through how I would approach reading and digesting these. By the end of this video, you'll have a good understanding of what's included in the civil drawings, what to look out for in the civil set, and also how the civil construction drawings ties into the rest of the building and the overall project. So let's go! Okay, so if you haven't checked out my other videos on how to read other sets of construction drawings, I always like to reiterate a couple main takeaways throughout those videos to develop not just your reading skills, but also how to read effectively. And I'm just gonna get those out of the way right now. Okay, so number one, don't get overwhelmed. Reading drawings can be mentally draining at times just based purely on the amount of information you're gonna be digesting, especially if this is the first time looking at a drawing set. So if you need to take a break, please do so. Number two, start with the larger picture before working your way into each set of drawings, that being your architectural versus your mechanical and so on. You don't see the world by looking through a microscope first. So I always start just by flipping through all the project drawing sets, general, architectural, structural, mechanical, electrical, plumbing. I'll read the sheet numbers and the sheet titles to just get the feeling of what the overall project's gonna be like. As I'm flipping through, I'm briefly looking at the highest level of details. Number three, once you get a good understanding of the project at a high level, go set by set and read every note, every detail, and read the entire specification booklet. I can't stress this part enough. Now you're probably wondering, why would I do this if we're only interested in the civil drawings? Well, similar to building a car, you don't just become an expert on the engine. You've got to understand the mechanics of how the vehicle works, how it corresponds with the structure of the car. You need to understand the shell, the paint, the interior detailing, because they all come together in order to work together. The same goes for any building. And number four, never assume. The same building can be built 100 different ways, and how you built it on the last project could be totally different than how you're going to build it on the next project. Also, different cities, counties, states, and even countries have different building codes and different ways of approaching construction in general. So to prepare ourselves before we get into these drawings, what are some things that we're going to find in a civil drawing set so we're not going in blindly? Well, I like to think of civil as everything outside of the building that's needed as a continuation of civilization. So that's your water lines from your local municipality that come into the building for people to drink. It's your sanitary and storm lines that leave the building when a toilet's flushed or after a major rainfall that goes back into the municipal plants to get filtered. It's gas or other process piping depending on the building. It's sidewalks, concrete stairs, handrails that connect to the community. It's parking lots, it's fire hydrants, it's directional signage such as one-way or stop signs. It's the grading of the land, which is essentially the topography that takes shape and everything is built on top of. So yeah, let's get into it. All right, we're gonna pretend we've already read the specifications and we've read through all the other drawing sets, and now we're actually on the civil set. We're gonna look at each of these sheet titles and then we're gonna drop back and go sheet by sheet. Okay, C0.0, the title sheet. So right off the bat, we've got C for civil, so we know we're in the right place. The title sheet is just going to summarize the project. It may or may not include key players and a list of applicable codes. C0.1, list of symbols and abbreviations. This is great because we're going to use this as a reference tool as we get further into the details. C0.2, miscellaneous construction details. C0.3, miscellaneous construction details continued. C1.0, existing and demolition site plan. If there is demolition on your project, each set, your architectural, electrical, mechanical, may have its own demolition plan, or sometimes the architect and engineers combine it onto one singular plan. C1.1, existing and site demolition plan continued. Okay, so this tells me that the project likely takes up a large square footage, which required the design team to split this project up into multiple sheets or pages. So I'm going to expect that from here on out, there's likely going to be 2 pages for each sheet title based on this split. C2.0, proposed site plan. This is where the bulk of the information is going to be and where I'd spend most of my time referencing back to this set of drawings through all these other drawings that we're going to be looking at. C2.1, the proposed site plan continued. Okay, so here's what I was just talking about with that split. And this is just based on the fact that this project takes up a large square footage. So the architect and design team split it up into these pages so that information is not too congested, making it difficult to read. C3.0, proposed site grading plan. C4.0, erosion and sediment control plan. So on a new commercial project, when you're cutting and moving dirt to change the topography, the soils actually become loosened, and during heavy rainfalls, that could wash away and enter into the public system. So these plans are in place for the course of construction to prevent that. C4.1, erosion and sediment control details. So this is just a follow-up to that last page, which shows different means to control erosion and sediment based on a handful of conditions we're going to find on this project. C4.2, erosion and sediment control details profiles continued. C4.3, proposed storm filter. This is showing a profile and also section cuts of a storm filter structure that would get placed underground as part of the stormwater management system. We'll get into that later. C5.1, proposed storm profiles. I'll briefly cover this at the end as well, but the engineers did a nice job providing a section cut and profiles showing how the system would look if you were looking at it underground. And finally, C5.2, proposed utility profiles. The same thing here, except it's just water lines and sanitary lines instead of the previous page, which were storm lines. Okay, so we flip back and we're on C0.0, the title sheet. It doesn't show much right off the bat, but it does have a map on it and a general vicinity of the building itself. Also, this would typically have a site address, but I've removed that for the time being. It may also have your engineer's contact information on it, as well as some other key players involved. Last, it may sometimes also include the codes that are referenceable throughout the project. Okay, the most important context on this page is the general notes. And remember, you got to read all the general notes. But for now, let's just take a look at number 3 as an example. So number 3 states that the location of the existing utility lines are for information and guidance only. That means it's not exact, mainly because it's underground and out of sight. So before starting any project, you need to call public and private utility locates to mark these lines to ensure that you're not going to hit anything if you are doing any sort of excavation during construction. You can also use a vac or a vacuum truck in areas that have highly congested underground utilities. It's essentially a truck that sprays high pressured water and sucks out the dirt as it explores downward into the earth. It's not going to damage the utility lines, so it's just an extra means of caution when there's high uncertainty as to where something may be located underground. Okay, so don't forget, read the rest of the notes and then we're going to get ready to move on. C0.1, list of symbols and abbreviations. Now, if you're brand new to construction, aside from Google, this page should be your best friend when it comes to reading drawings. No drawing set is perfect, but these will give you a standard indication of what you're looking at. Architects and engineers use different drawing symbols between different companies and different projects, so these can possibly change. So understand what they are for this project specifically, because it'll give you context moving forward. Okay, let's look at a quick example. I'm going to look at this one in particular. It's a line with UE through it forming this symbol. I'm going to jump to C2.0, the proposed site plan, to explain this. Okay, here we are. I'm zooming in and I can see this UE line. So I know that this means that there's an underground electric line in this approximate area, because that's what that symbol identified on the previous page. Now remember our title page general notes that the locations of these lines were for guidance purposes only. The engineer might know that this underground electrical line goes from this building to this building, so they drew a line connecting the two. They don't necessarily know its exact location or its exact depth, which is why we'd call for a locate or potentially a vac truck. The reason I bring this up is because all these notes are typically related to each other, which is why you have to read all of them, and this is a good example of that. Let's jump back to C0.1, the list of symbols and abbreviations. Now I want you to take your time and go through the rest of the symbols and commit them to memory, because it's going to save you a tremendous amount of time when you're flipping through these drawings seeing these symbols. Also, the same goes for abbreviations. Now you're going to take your time here, read them all, and commit them to memory, because it's going to do the same thing. It's just going to save you time when you're reading through the rest of the drawings. Now let's just read a couple before we move on. So here we have FH, fire hydrant. Here we have HMA, hot mix asphalt. And finally, we have MH, manhole. Okay, let's go on to the next page. C0.2, miscellaneous construction details. So this is going to show us enlarged details of aspects of the project that we're going to find later on in this civil set of plans. Okay, let's zoom in on detail 8 on this C0.2 page, low volume pavement section detail. The bottom states a proof rolled subgrade. A proof roll in construction is when you take a construction vehicle of a certain weight and you roll it over an area to ensure that the vehicle isn't going to sink or create tire rutting. You want high density compacted earth to provide strength and longevity to everything you build above it. So it won't matter how many times you compact your top layers if you don't start with a well compacted subgrade. This is because your subgrade could loosen over time, therefore loosening these top layers. Okay, so the note right next to this states 6-inch CR6 aggregate placed and compacted in 2 equal lifts. So if you don't know what CR6 is, first we check the specifications along with our abbreviations page, and if we don't find the answer there, go and check Google or clarify it with with a design engineer. What are 2 lifts? Well, you can't just put 4 feet of stone down and try to compact the very top. Again, because the bottom is going to stay loose. So whenever you're building up and out of the ground, you build it up in lifts to ensure each layer is getting adequate compaction so that it can safely support the layer above it. All right, next it looks like we've got 2 layers of HMA. Wait, that sounds familiar. Well, if you recall from our abbreviations, HMA stands for hot mix asphalt. So this is a good reason why we read that abbreviations page. All right, keep this detail in mind as we move forward. Let's jump to C1.0. We're gonna pretend that we read every note and we stumbled on this saw cut existing paving note. Well, we've got a saw cut here, so I'm assuming something's gonna be going under this section of paving. Okay, so we're flipping around these pages so that I can show you how everything is related. So next we're gonna jump to C2.0, the proposed site plan. Okay, we're gonna zoom in on that same area. I see 48-inch HDPE going right where we're going to saw cut, which is the purpose for that saw cutting. Again, we know what HDPE is because we either read it on the abbreviations page or we Googled it. So I'm gonna now jump all the way back to the first page that we're on, C0.2, where our original detail was. Okay, I'm gonna assume that we read all the details on this page, and now we're just gonna focus on 3 of those details. One of the details is gonna be the detail that we originally looked at. The next detail is going to be this detail 3, utility trench detail in new paved areas. Let's just take a quick look at this. Okay, right above this detail is detail 2, utility trench detail, existing paved areas. So thinking back to that other page where we saw cut the pavement and we're going to install that new 48-inch line HDPE, which one of these details do we use? Okay, so we're just gonna use some context in this scenario. So we know that there's a pipe under this section, so that first detail we looked at didn't have a pipe in there, so we can't technically use that detail. The other 2 details, one is for existing paved areas and one is for new paved areas. So let's just use some context here. We know that the drawing just showed us cutting into the existing parking lot. So on this detail, we can clearly show that this is drawn to show that cut as well. So we're going to use this detail 2 on C2.0 for that instance. So the fact that these other 2 details exist really tell us that these details are used or prevalent in this project somewhere else on this drawing set. Okay, let's focus in on detail 2 on C2.0 utility trench detail existing paved areas. Okay, there's our HDPE pipe. We remember what the CR6 is from our previous detail. We see that this calls for 6-inch bedding below and above the pipe, which helps ensure that the pipe doesn't break and that it's set properly. We see a couple notes on the side, 95% mod and 97% mod, and these are just 2 different testing standards for compaction, which you should be able to find in your specification sections. If not, again, you can always Google what they are if you don't know what the meaning of something is on your drawing set. Okay, so it doesn't necessarily show it on this detail, but we're likely going to have to install a tracer wire, which is a thin metallic wire that follows the pipe wherever it gets installed. The reason for installing this tracer wire is because the pipe is essentially plastic and it wouldn't get detected from the public and private utility locates equipment when they came out to the job site. So we put this tracer wire in place to ensure that if anybody were to excavate down or call for a utility locate, they would know that this pipe existed. So in addition to this, we also complete a set of as-builts and we provide that to the owner. So if they ever decide to do a new construction project in the future, they can actually see where we installed these in relationship to the original contract documents. Okay, so above that, there's a detectable warning tape called out, which is the last means of protecting this pipe from future excavations. If there was someone excavated and they hit this tape in the ground, they would know to stop excavating because there is going to be a pipe immediately below that, and then they can proceed with caution. Okay, so the last note is actually a safety note. Because we're only saw cutting a small width to limit the demolition of the parking lot, it creates a safety concern. Without the parking lot, you can bench or slope your excavations and create wider trenches to prevent collapse and injury to the individuals who are getting in those excavations. In a situation like this, benching and sloping is not achievable because you have existing parking lot on the sides. So a trench box with a ladder as the means of exit is going to be likely used in this scenario, which is just force against the sidewalls to prevent soils from collapsing in on the individuals who are going to be in the excavation working. So we're going to read the rest of these drawings on this detail page, and then we're going to move on to C0.3. Okay, so we see stair details, a fire hydrant details, and some other general notes. The big item I want to point out on this page is the proposed storm inlet and manhole report. So storm systems have piping that leaves a building or collects in a curb and gutter system or a bioretention system and continue through underground piping until they enter these structures. They do this all throughout the underground system, entering and exiting at different inverts. An invert is the bottom elevation of the pipe's interior wall, not the bottom of the pipe itself. So everything is based on gravity capacity and flow. So your inverts exit at one elevation from one structure and enter into another structure at a different invert until the water is carried away from the site. This is how storm structures are built before they make it onto the job site. Okay, moving on to C1.0. This is showing all the demolition that's going to be required on this project. I would just note that it shows trees being demoed in the civil set. You may find this in the civil, you may find this in the landscape drawings. It all depends on the architect and engineers putting together these drawing pages. I'm not going to spend too much on this drawing set because demo's pretty simple. You just got to remove it before you can start that next activity. Let's move on to C1.1, which is just a continuation of that. Okay, so looking at this page and thinking about demolition in general, the main takeaway is just considering how we would sequence this work. Does it serve the project to just demo everything at once, or would having part of the parking lot left in place serve as a better means, such as material storage or for a trailer? So all things to consider. You don't want to just uncover work just to uncover work if you're not ready to put the new work in place. Okay, moving on to C2.0, which is going to be the bulk of the scope on this project. This is where all those enlarged details that we were previously looking at are going to come to life. Okay, so zooming in, we see that 48-inch HDPE line again, and we notice this arrow, which is going to tell us which way it's sloping, because if you remember, we need gravity to carry water away from the site. Now, I didn't specifically mention it, but if you recall from the storm inlet and manhole report, I3 was a name of one of those structures. So now we see 3 pipes entering, and if we go back to that report, we can see the inverts of those. And of course, the 3 little pipes need a larger pipe to carry away that storm water so that it doesn't back up. On the opposite end of this pipe, we see an odd looking structure, and we're just going to keep that in the back of our mind because I know that's going to come up later in this drawing set. So moving along, we see that there's sidewalk called out, and we also see some signage and where that needs to be placed on this job site. If we look top left, there's a sidewalk scoring plan, which gives us in a large detail of the joint layout in that sidewalk. Keep moving forward, we see a lowered planter bed, and it looks like this is where some of that water collects and flows into that storm system that we were just looking at earlier. Okay, so we're just going to keep doing this throughout this page, and then we're going to move on to C2.1, which is a lot of the same conditions. So we're not going to spend too much time on this page. We're actually going to move on to C3.0. Okay, so C3.0 is your final grading plan, which again is just the redistribution of site soils throughout the site through cuts or removal or fills, adds to the soil. So this is where you see your earthworking contractor with all that heavy equipment pushing around the soils to sculpt the landscape and the topography to ensure sidewalks tie into the existing sidewalks, the building's elevated, the pad is built up properly underneath it, and just water flows nicely throughout the site. And what they do is, if you zoom in on this drawing, you can see the contour lines actually have different elevations. So this is what the earthworking contractor is going to follow. So most earthworking contractors are going to request the civil CAD file, which is just the 3D file associated with this 2D drawing. The earthworker can take these files and upload them into their earth moving vehicles and equipment, which would give them high levels of accuracy based on GPS or control points to ensure that the topography is being met very closely. So moving on to C4.0, the erosion and sediment control plan. So as all this heavy equipment is loosening up all this dirt and all this sediment, they have to have a means to control that from just leaving the job site during a heavy rainfall. In addition, you can see at the entrance of the construction site, they have a tracking pad, which is usually some loose stone put down to just keep the dirt from falling off the tires of the trucks as they leave and enter onto city or county roads. And we'll look at one more item. There is a temp asphalt berm note, which tells us to look at detail C5. So let's jump over to that C5 page. So just quickly, for things to make sense, you have to do this sort of bouncing around. You have to follow the detail until you kind of understand everything associated with that detail, and then you kind of return back to some previous pages and do that again. You do it over and over until you kind of understand how all these details intertwine, not just within the civil set, but within all the other sets, such as architectural, structural, etc. Okay, so I'm on the C5 page. I'm going to read all these details, but I'm going to just focus in on this asphalt berm detail because we're just looking at this. And as long as we construct it this way in this temporary condition, that's what they're looking for, and we're good to go. Okay, so I'm going to jump over C4.2 because it just looks like it's a continuation of that erosion and sediment control with more details. Okay, so we're on C4.3, and it looks like we found that odd structure that we were looking at earlier. So I'm going to read everything on this page and read all the details and all the notes to further explain and put some context as to what this structure is going to look like, how it's going to be built, and how it's going to get installed. Okay, so we read everything, and it looks like this structure's purpose is just to filter the stormwater further before it enters back into the city or county stormwater system. We can keep moving on. Okay, so on to those last 2 pages and their profile pages, or more so just section cuts of what we're looking at underground. Well, I remember the I3 and the I4. Those were those 2 structures that we looked at earlier on both the storm inlet and manhole report, as well as the proposed site plan page. This is telling me exactly how many linear feet this pipe is, what the inverts are, all in relation to existing ground elevations. Okay, so that's really it. I don't think we need to go further in depth. This job had limited asphalt paving that you'd also find in the civil set. We focus mainly on the storm system, but remember there's also water lines, gas lines, sanitary lines to function properly as a building. So there will be specific details for all that as well, just depending on the project itself. The techniques of reading those details are all going to be the same. So just remember to look back at the symbols, the abbreviations, and equally important, the specifications to put everything into context. The specifications will actually tell you material types you have to use, such as stone types, as well as installation requirements. Okay, so thank you for sticking around to the end of this civil drawing set review. I really enjoyed putting together this video, and I hope you picked up something along the way that you previously didn't know. If not, I hope you just had fun watching. The only way to get better is practice, and also try helping someone else out. Explaining things to someone else will help reinforce your own knowledge of the subject, and you might learn something new along the way. So as always, be better, build better, and bye for now.